Okay, so let's keep moving through here, talking a little bit more about circles. And one of the things you're going to have to do when you're working with your circles today is a little bit of an algebra review, which is going to be, you're going to have to remember how to solve quadratic functions by factoring. So I thought it'd be a good idea if we went ahead and did a couple of these to review. Just some basic steps written up here. The first thing we always want to do when we are solving is to get it set equal to 0, because we are finding the zeros of the function. Second, we want to look and see if there's a GCF. A GCF is a greatest common factor that we can take out of all the terms. And then we actually go ahead and factor, and if you think back to Algebra 1, you would say what times what equals A times C, and what plus what equals B. And we'll talk about how to do that. And then you would use those factors to write it in factored form. And then you would set each factor equal to 0 and solve. And since we have a quadratic here with an exponent of 2, we should have 2 solutions for each problem. So we should be getting 2 answers. So let's go ahead and look at the first one. So the first one we have is x squared plus 8x minus 48. So if we look at our steps, set it equal to 0, check, we've already got that done. We look if there's a GCF. Well, there's the lead coefficient out here in front is 1, out in front of the x squared is 1, which means there's not going to be a greatest common factor because you can't take anything out of 1 besides 1. So now we want to think about how we are going to factor it. And if you think back, we would always say what times what equals AC. Well, in this case, A is 1, C is negative 48. So what times what equals negative 48? And what plus what equals 8? Okay, so then we need to think about our factor pairs of 48. We'd have 1 and 48, 2 and 24, 3 and 16, 4 and 12. As I hit 4 and 12, I realize, okay, I know I can get 8 out of that. I need to get a positive 8 and a negative 48. So one of my numbers here is going to be positive and the other one's going to be negative. So I'm going to have a negative 12 and a positive 4. Those multiply together to be negative 48. Oops, we don't want we want positive 12, negative 4. Those multiply together to be negative 48. And if we add 12 and negative 4, we get 8. So these are going to be our 2 factors that we're going to use. So we are going to use 12 and negative 4 when we write our factors. And if you remember how we do that, we would write our parentheses like this. And we would have x. One of these numbers we have is positive 12, so it would be plus 12. And then we would have negative 4, so it would be x minus 4. And then, so that's written in factored form. And then what we would do next is we would set each of these equal to 0. So x plus 12 equals 0, and x minus 4 equals 0. If I subtract 12 from both sides, I get one of my solutions is negative 12, and my other solution here, if I add 4 to both sides, is 4. Okay, so let's just keep working our way through here and look at a couple more examples. All right, and kind of see our steps here. Step 1, we want to get our equation equal to 0. Currently it is not, so I need to subtract 18 from both sides. So I'm going to subtract 18 from both sides, and I get x squared minus 3x minus 18 equals 0. Our next step is going to be to look for a greatest common factor. Again, that lead coefficient out in front is 1x squared, which means there's not going to be a greatest common factor. Next, we're going to look at what times what gets us negative 18, and what plus what equals negative 3. So we need to think about factors of negative 18. So we know that one of them has to be positive, one of them has to be negative, that multiply to be negative 18, add together to be negative 3. And so we have negative 6 and positive 3 multiply to be negative 18, and negative 6 and positive 3 also add together to be negative 3. So we're going to use these two are going to be what goes in our parentheses as a factor. So we're going to have x minus 6 and x plus 3. Again, that's just those factors that we just had there, equals 0. If we set each of these equal to 0, we would get either x equals 6 or x equals negative 3. Okay, so we're moving on here. The problems get just a little bit more difficult each time. So maybe some bigger numbers and greatest common factors. So our first step, 1, is we're going to get it set equal to 0 first. So I'm going to add 15x to both sides, and I'm going to add 10 to both sides. So I'm going to add 15x to both sides, and I'm going to add 10 to both sides. So I would have 5x squared plus 15x plus 10 equals 0. So we got it equal to 0. That's step 1. Step 2 is I'm looking for a greatest common factor. I have a 5 out in front. So I'm going to look, my greatest common factor of 5, 15, and 10 is 5. So I'm going to take a 5 out of each term. And to help me remember that I'm taking it out of each term, I show that I'm dividing each one by 5. Whatever my greatest common factor is that I took out, I put that on the outside of the parentheses, and my leftovers go on the inside. So 5 divided by 5 is 1, 15 divided by 5 is 3, and 10 divided by 5 is 2. Now we are focusing on our quadratic that is inside here, and we are thinking what times what is 2 and also adds to be 3. Well, the only factor pairs of 2 are 2 and 1, and lucky for us, 2 times 1 is 2, and 2 plus 1 is also 3. So let's not forget that 5 on the outside. And now I'm going to have my 2 sets of parentheses. I'm going to have x plus 2 and x plus 1 equals 0. This 5 on the outside, since if we try to set it equal to 0, 5 does not equal to 0. So we can leave that off of our answers, and we would just have x plus 2 equals 0. Actually, technically, we could say that one of our factors is 5. If we say 5 equals 0, 5 does not equal 0, so we don't need to worry about 5. And then x plus 1 equals 0. So our 2 solutions are going to be x equals negative 2 or x equals negative 1. Okay, last one. Why don't you go ahead and pause the video and see if you can do this one on your own. Try it. Get your equation equal to 0, find your greatest common factor, factor it out. You should have 2 solutions when you get finished. And then come back, and if you have any questions about it, I'll have a solution here for you to look at. But when you get finished, you can always ask questions if you're still struggling with this. Okay, go ahead and take a look at my solution here and see if it matches what you have. And if it does not, please go ahead and bring your work back so I can take a look at it, and we can answer any questions that you might have. Okay, so now we're actually going to use some of that algebra in order to figure out some things about segments in a circle. We've done a lot with segments in a circle with arc measures and lengths and all that good stuff. Now we're actually looking at the lengths of the segments and how they're related to each other. So if you have 2 segments, or 2 chords, excuse me, if you have 2 chords that meet inside the circle, or in the interior or the inside of the circle, so, and they do not have to meet in the center of the circle, they can meet anywhere inside the circle, then the relationship that they have is that the way they explain it here is EA times EB. That would be EA times EB, which is one part of that segment times the other part of that segment, equals DE times EC, which is the blue segment, one part of the blue segment times the other part of the blue segment. So the way I think about it is when you have these segments or chords that meet inside the circle, you're thinking part times part equals part times part. So you're taking one segment and multiplying the parts of that segment times each other. So for instance, with numbers, what that would look like, here on our first example, our first segment is, I'm going to highlight here in blue, and the 2 parts of that segment, we have 3 and we have x, okay? So part times part would be 3 times x. And then our other segment, let's do it in a different color here, is 6 and 4. So those 2 parts, you're going to multiply 4 times 6, the 2 parts of the segment. So we'd have 3x equals 24, so x equals 8. Okay, Okay, so let's look at just another example of that here, getting just a little more involved with our algebraic expressions. So we would have part times part. So we'd have, here's one part, here's the other part of that red segment. So we'd have 3 times 4 is 12. And then this segment, one part is 2, the other part is x plus 1. So we are going to multiply them together. So 3 times 4 is 12. And then we multiply 2, and we distribute it in there, we get 2x plus 2. If we subtract 2 and divide by 2, we would get x equals 5. Okay, obviously this one's a little bit more involved. It's got several algebraic expressions. So first of all, we have 2 chords that are meeting inside of the circle at point N. Let's identify the parts of the circle, right? So here is one segment here, or one chord, and the 2 parts of that chord are x plus 1 and x plus 2. The other chord that goes across this way, the 2 parts of it are x and x plus 4. So we are going to multiply part times part, so we would have x plus 2 times x plus 1. And then the other one would be x times x plus 4. And remember, when you're multiplying these two together, x plus 2 times x plus 1, you can either FOIL if you want to, or you could make the box down there if you want to do the box method. I'm going to go ahead and FOIL it this time, just so we can see some different methods. If I have x times x, I get x squared. X times 1 is 1x. Then I'm going to go with the 2. 2 times x is 2x, and 2 times 1 is 2. On the other side, x times x is x squared, and x times 4 is 4x. Okay, notice on the second one we only had to distribute once because the first factor is just x. So then we can go ahead and solve. If I subtract x squared from both sides, my x squareds cancel because x squared minus x squared is 0. If I combine these terms here, I'd have 3x plus 2 equals 4x. Well, I want to get x all by itself, so I'm just going to subtract 3x from both sides, and I get 2 equals x. There wasn't really, you didn't have to do all the factoring just yet on this example, but don't worry, we will as we go forward to this section. Okay, so the last one was when they met inside a circle. So you had 2 chords that met inside of a circle. This time you have 2 secants. Remember, secants, in this, they're secant segments, which means they go through the circle and they have endpoints. And one of the endpoints is going to be outside the circle, and one of the endpoints is going to be on the circle. And the way that this works, if you notice, if you look, we have, here's my secant segment, and here's my secant segment, okay? They meet outside the circle, and the other ends of their segments are on the circle here. They also intersect the circle at A and C. And the way that this works is when they meet on the outside of the circle, the way I like to think about it, rather than EA times EB and things like that, EA is on the outside, is the segment part that's on the outside of the circle. EB is the whole segment. So we take outside times whole equals outside segment, which is EC times the whole segment. So what that's going to look like on your diagram, let me erase this stuff I have on here, is let's highlight some things. We're going to take the outside times the whole, okay? So we would have the outside times the whole is going to equal the outside times the whole thing, the whole segment. Okay, so let's take a look at how you'd actually do that. Here we have an example down here. And, okay, so here's our segment. We have, let's look at RQ first. Okay, So we have the outside part of the segment goes from R to P. So the outside is 9. The whole segment is 9 plus 11, which is 20. Again, you cannot just assume that the two numbers that are there are going to be the two numbers that you multiply together. Okay, so the outside times the whole, that's 9 times 20. And then the other one is the red one there. The outside part is 10. The whole thing, you add them together, which is going to be 10 plus x. So now we go ahead and we solve. 9 times 20 is 180. 10 times 10 is 100. 10 times x is 10x. If we subtract 100 from both sides, I get 80 equals 10x. X equals 8. Okay, so be very careful. You cannot just multiply 9 times 11 and 10 times x. It does not work that way when the secants meet on the outside of the circle. Okay, let's look at a couple more here. Okay, so let's identify our segments here, our secant segment. Okay, this first one is here. Okay, outside, the outside part is 6. The whole segment is 9 plus 6, which is 15. And then we have the other one. We have this blue one. The outside part is 5. The whole thing is x plus 5, because to get the whole thing you have to add the two parts together. So we'd have 90 equals 5x plus 25. If I subtract 25 from both sides, I get 65 equals 5x. If I divide both sides by 5, I get x equals 13. All right, and as you can see, this last one is going to be a little bit tricky because there's a lot of things going on in this problem. Okay, we got some algebraic expressions in here rather than just numbers or a single x or something like that. So we're going to have to think about this one a little bit harder. So let's find our first segment. We have our first secant segment is this guy right here. The outside is 4. The whole thing is 4 plus 5, which is 9, equals the outside of the other one, which is x minus 2, times the whole thing. Let's do a little thinking bubble over here real quick. Here's my little thinking bubble. If I add x minus 2 plus x plus 4, because I have to add both parts together to get the whole thing, what do I get? Well, my like terms are x plus x, which is 2x, and negative 2 plus 4, which is 2. Okay, so again, you're not just multiplying x minus 2 times x plus 4. So I need to multiply some stuff out here. I get 9 times 4 is 36. This time I'm going to show you, rather than doing the FOIL method, I'm going to do the box method down here. If you like to FOIL, you certainly can. I'm going to do x and negative 2. I'm going to do 2x and positive 2. 2x times x is 2x squared. 2x times negative 2 is negative 4x. 2 times x is 2x, and 2 times negative 2 is negative 4. Here in the middle, I get my like terms, so I would have 2x squared, and then 2x minus 4x is negative 2x minus 4. Okay, so now I've got this quadratic here. Go back to slide 1. What do we do first? We get our equation set equal to 0. So now I'm going to subtract 36 from both sides. And those of you that took good notes and probably remember we've already factored this once. This was one of the examples that we did, but we'll go through the process again. So I would get 0 equals 2x squared minus 2x. Negative 36 and negative 4 is negative 40. Have it set equal to 0. I take my greatest common factor out of all of 3 of them, and I get 0 equals 2 times x squared minus x minus 20. Same idea that we've done before. What times what equals negative 20, what plus what equals negative 1, and we've already done this example. It's negative 5 and positive 4. So our two factors in our parentheses are going to be x minus 5, x plus 4. Again, 2 does not equal 0, so we don't need to worry about that. If I say x minus 5 equals 0, I get x equals 5. If I say x plus 4 equals 0, I get x equals negative 4. However, we have to be careful because if there's one thing we know about segment lengths, it's that they cannot be negative. So you have to be very careful with your answers that you get, because if I have x equals 5 and I come back up here and I put my segment that x equals 5 in, my outside is going to be 3, my inside is going to be 9. If I put negative 4 back in here, negative 4 plus 4 is 0. You can't have a 0 segment length. And negative 4 minus 2 is negative 6. So you can't have a negative segment length. So negative 4 does not actually work. The only answer that actually makes sense for this problem is x equals 5. Okay, so now we have one more idea that we need to do. So the first thing that we did two chords meeting inside a circle. Then we did two secants meeting outside the circle. Now we're going to have a tangent and a secant meeting outside the circle. Okay, so outside the circle, this is going to be this. You're going to do the exact same thing that you did on the other one. You're going to have a tangent, which means it's going to be a segment that goes to the circle like that, and then you're also going to have a secant that goes through the circle and intersects it also at this point. And what we're going to think about is the same idea that we just did when they were both secants, where you're going to take the outside times the whole, and it's going to equal the outside times the whole. However, what makes it a little bit different here is when you're looking at a tangent. So let's look at number 7. Okay, we've got my tangent here. From here to here is 10. Well, the outside part of that is 10, and the whole segment is also 10. So you're going to have 10 times 10. So that's the outside times the whole. And then when you have your secant on the other one here, the outside, just like before, the outside is 5. The whole is x plus 5. And then you just go through and you solve them like you have. 10 times 10 is 100. 5x plus 25. If you subtract 25 from both sides, you get 75 equals 5x. And divide by 5, and we get 15 equals x. And that's an okay answer because that does not make any kind of an issue with a negative segment length or anything. Okay, so let's try another one here. We've got, here's our tangent that goes from here to here. And then, so the outside part is x, and the whole thing is also x. With our secant, okay, our outside part is 9. Our whole part is 9 times 7, or excuse me, 9 plus 7, which is 16. So x times x is x squared. 9 times 16 is 144. We don't want x squared, we want x, so I'm going to go ahead and take the square root of both sides, and we'd get x equals 12. Remember, when we take the square root of both sides, generally we would put plus or minus in front of that. However, we can't have a negative side length, so we know that the negative value for x is not going to make sense with our solution, so we are only going to take the positive value, which is just x. Okay, last one here. Okay, we have a tangent because it's on the outside and it only touches once. So that tangent, the outside part, is x plus 4. The whole thing is x plus 4. Okay, The other one is our secant. That's going to be the blue. The outside part is x. The whole thing is x plus 12. Okay, so I want you to, I kind of got it set up for you. I want you to go ahead and pause the video. Try this one on your own, and then I will post the solution here in just a second. And if you don't get the right answer, if you have any questions about how to do it, please go ahead and come and ask us. We'd be more than happy to help you with how to solve it. Okay, so go ahead and double check with what you have with what I have and make sure that your answer is correct. And if you have any questions, please let us know. And there is a class kick for you to work on when you get done.